All right, thank you everybody and welcome to today's webinar, CBRS for Oil, Gas, and Utilities. What is OnGo? I'm Greg Kunkel from Keller and Heckman. I'm the co-chair of the NLEC Regulatory and Technology Spectrum Subcommittee. Really excited about today's webinar. CBRS and OnGo are topics that we get questions about all the time, and we have several experts here to talk to you about this technology and applications for critical infrastructure companies. Move to the next slide. Couple of notes, housekeeping notes before we get started. We have, NLEC has a couple of upcoming events. One on Wednesday, July 29th, an upcoming webinar on planning communications infrastructure for mission critical mobility. There's likely to be at least one more webinar coming in July. Check the link there that's up on the screen to keep up to date on the schedule. Also, the NLEC Conference and Expo is scheduled for August 11th through the 13th. A decision was just made that that conference is going to be virtual in light of the issues with COVID-19. So stay up to date. There'll be more information coming from NLEC with details about how that conference is going to work, but those dates will remain just in a virtual manner. Next slide. All right, so let's go ahead and get kicked off and introduce today's speakers. We've got 4 speakers today. Alan Ewing is the Executive Director of the CBRS Alliance, an industry consortium of more than 100 wireless and telecom organizations who believe that LTE-based solutions in the 3.5 gigahertz band utilizing shared spectrum can enable both in-building and outdoor coverage and capacity expansion at massive scale. Kurt Jacobs, Director Solutions of JMA Wireless. He has over 20 years of emerging communication technologies development and system deployment experience. For JMA, he leads solution and ecosystem development activities for mobile connectivity in the enterprise, industrial, government, and large venue markets. He recently retired from a 30-year active and reserve duty career as a U.S. Navy officer. Jonathan Shaw-Hart has spent the past 4 years at Cambium Networks following a 12-year stint as the VP of Sales and Marketing Strategy at Hutton Communications. One of Jonathan's chief accomplishments at Hutton was building a new business unit serving the industrial markets, including oil and gas. He is also a member of the NLEC board. And Ron Ivey, Managing Director for IM Services Group. His extensive knowledge and experience in the creation, development, and successful deployment of telecommunications and energy management projects, a background of 20+ years in the industry, provides the solid foundation of expertise, ability to execute projects from concept to operations. One note about this webinar, the microphones are muted for the participants. If you have questions, at the bottom of your screen, there's a Q&A box. Please enter your questions as we go. And time permitting at the end, we will answer those questions as we've received them during the conference. So with that, I'm going to turn it over to Alan Ewing to get the conference started. Thank you.
Thank you, Greg. Appreciate the introduction and appreciate the opportunity to share our story with your audience. So my job here is to give you a high-level view of where we've come in CBRS and OnGo. There's a lot of terminology here. Hopefully we can help navigate. So at the next slide, basically, in the highest level way we discuss this when we're bringing this message to various audiences, one of the things that we say is OnGo is opportunity for innovation. When this band was first defined by the FCC, a lot of our members referred to it as the innovation band, because what it did is it opened up 150 megahertz of spectrum for shared use. And in that, what that allows for is a lot of non-traditional applications are now able to leverage the carrier grade technologies of LTE, and in addition, a pathway to 5G and R. So this is all about leveraging that available spectrum and the really robust radio technologies that LTE and 5G and R bring to the table. Next slide. So a brief history of CBRS, and this is essentially the from shared spectrum to private LTE. If we go through this quickly, there's some key dates that we want to mention. So if you could take us through those dates. 2010 is when this band was identified for possible shared use. The FCC in the background, working with NTIA and the Department of Defense, defined the requirements for what became known as Citizens Broadband Radio Service, or CBRS, 2013. The Alliance, who I represent, and many of the folks, Kurt is also part of a member company, as well as many others, was formed to support that mission of bringing LTE and, at that time, of course, way down the road, 5GNR into the band. The 2018 year is when we brought forth the OnGo branding. And here, OnGo branding, and when you talk about OnGo, OnGo is simply put LTE and now 5GNR in the CBRS band. So it covers all of the technology, the services, etc. In 2019, a banner year for us last year, the FCC did approve the initial commercial deployment of the band and turned on the lights, as it were. And then very early in 2020, the full commercial deployment was approved by the FCC, and then it was literally game on for the deployments in the band. Next slide. So why is the spectrum shared? So historically, what we talk about in this band, the Citizens Broadband Radio Service band, was allocated for use by other parties, and we refer to those as the incumbents. So you will hear that term used quite a bit. The primary incumbent is the US Navy, but in addition to the US Navy, fixed satellite stations, as well as wireless internet service providers, had access already to the band and are referred to as the incumbents. So in order to make this concept of spectrum sharing work, really the key element of all of this is, simply put, a traffic cop. Who gets the spectrum where, when, how? And a traffic cop that helps make sure that allocations are done properly and that interference is limited as much as possible, and if not completely. So this traffic cop also ensures that the incumbents get the use of the spectrum when they need it, but also they allow shared access to commercial deployments when they don't. The key element in this, the traffic cop, is actually known as the Spectrum Access System, and we refer to it as the SAS. Next slide. So here's just a quick view of the spectrum itself. This is 150 megahertz of spectrum, and to give you some context about what that means, 150 megahertz of spectrum is an enormous piece of spectrum real estate. Many of the mainline mobile network operators do not have 150 megahertz total that they deploy their networks in the mid-band. So, this idea that, this is just a little chunk over in the corner, no, this is prime real estate. What you see in this picture are the hierarchy of the sharing mechanism. On the top, as I mentioned before, the incumbents. So these are the Department of Defense, the Navy, ship-based radar, ground-based radar, the fixed satellite service folks, and the WISPs. Though the WISPs do have to transition from the rules they operate under today to the rules that we will all operate under in the CBRS band. So there's a transition that they're going through right now. The next level that you see is what's known as PAL, Priority Access License. This level is enables folks that are interested in deploying commercially to purchase a license through an auction mechanism that is running right as we speak with the FCC. So we're in what we refer to as the quiet period for the PAL auction. So folks can't discuss their strategies or what they're doing in that regard. We do know what's happening. What this is up to 7 10 megahertz licenses in the band. And what it does is it gives prioritization over the next tier, which is known as General Authorized Access. The GAA, for short, is the spectrum. If no one's using it above, it is fully available for commercial use. So they are down the priority table, but there's always a section of spectrum that is allocated for GAA regardless. Next slide. So just a little bit about the technology, and as we click through some of these points, the animations, what you see here is how all of this is set up architecturally. So you notice there are SASs, there are more than one. In fact, there are 5 that are currently approved. There are 5 different commercial entities that offer traffic cop services, which the idea behind that, of course, is to create competition, and competition helps manage pricing. So you look for the best deal in your SAS service that you contract with. The SASs must be in communication with the infrastructure devices. Again, because we are telecom, we love acronyms. What we refer to on the infrastructure side are CBSDs. And the CBSDs are the radios, the bits that are actually the base stations, if you like, small cells, eNode Bs, access points. There's all different flavors of CBSDs, and that's why we have a generic term. What you notice above the SASs is the mechanisms that help enable the traffic cop to be able to do its job. So there's an FCC database that maintains an enormous amount of information about the fixed satellite guys, the WISPs, and et cetera. There's also a mechanism that allows us to detect when the radars are operating in an area from the ships, which we refer to as ESC, environmental sensing capability. But all of these pieces together, what they offer is the ability to manage the spectrum and share it effectively. Think of it again like a traffic cop. She's watching the flow of traffic on the road and making sure there aren't any collisions, that everybody gets good use of the road, and everybody gets to what they want to do in a reasonably efficient and safe way. So that analogy is pretty apt. Next slide. So what's OnGo? We keep talking about CBRS. Well, OnGo is the brand name. CBRS is the name of the frequency band. So just like Wi-Fi is a brand name for 802.11, IEEE 802.11 and the unlicensed bands, which is a bit of a mouthful. You like to say Wi-Fi instead, and everybody knows what you mean. OnGo is the brand name for using LTE and eventually 5GNR in the CBRS band. So the idea here is, very simply put, OnGo is all about LTE, 5GNR in the CBRS band. So when somebody says OnGo, you know they're talking about one of the most widely deployed, robust radio technologies in the world, and they're talking about it in the context of spectrum sharing in the CBRS band. Next slide. So what makes OnGo different? LTE is carrier grade communications technology. This is the same technology that we all enjoy every day on our phones. We've come to rely on it. It is remarkable, the scale and size of the deployments for LTE worldwide. The CBRS band is lightly licensed shared spectrum, and the idea there is the kind of opportunities that we open up in different use cases really, isn't that it can't be done by other types of deployments, but it's certainly one of the most robust ways to do this in a wireless network. The other aspect of this is, essentially it gives the simplicity in many respects of deploying Wi-Fi with the robustness of carrier grade connectivity. So a lot of the things you like about being able to do things quickly, easily, etc., there are rules, and we have to be careful because we are talking about lightly licensed spectrum, but the level of simplicity to get that kind of robustness is a wonderful trade-off. Next slide. And then finally, what can OnGo do? OnGo can support a lot of different use cases. We have a discussion within the CBRS Alliance of everything, of course, oil and gas, utilities, but we also talk about education. We talk about medical. We talk about wireless internet service provision. We talk about public safety. We talk about smart cities. We talk about industrial IoT, large venues, sports venues. So the thing about OnGo is in the spirit of being the technology behind the innovation of the innovation band, is it really does enable an almost unimaginable list of different ways to use it. So all of the flexibility of cellular all the flexibility of Wi-Fi, all the robustness of cellular, indoor, outdoor, this is really a panacea for those that wish to take advantage of it. Next slide. And then, sorry, one more I believe here for me is, this isn't a theory, this is reality. So from the point of view of end user devices, there are already over 81 unique devices authorized by the FCC, including a multitude of phones, laptops, tablets, modems, dongles, modules that can be put in all different types of devices and other custom use devices. There are scanners, for example, product scanners that are CBRS enabled, OnGo enabled. And then on the access point base station side, 47 today, with that number growing dramatically all the time as well. Both indoor and outdoor use case type of devices. Next slide. So we have now, as of today, 168 member companies. We're growing in spite of the fact of the challenging times that we live in. We operate as a standards development organization, and we're here to bring LTE and 5GNR to the CBRS band, make it accessible, make it successful, make it available for everyone to take advantage of. Next slide. And here you see just a quick view of our membership. A lot of familiar names, our board of directors, some of the most celebrated companies, and a lot of non-traditional companies, right? These are not just telco companies. These are technology companies and looking to leverage the innovation. Next slide. And there we go. And I'm going to hand it over to Kurt Jacobs to carry on.
Thank you, Alan. I'm Kurt Jacobs with JMA, although I'm primarily here with my CBRS Alliance hat on. I chair the marketing working group and involved with all the CBRS Alliance working groups, from the technology, test certification, deployment and operations, and business. So the CBRS Alliance is definitely more than just technology. It's about bringing that full ecosystem together. But also through my experience, through my day job, work on, with customers in many different verticals that have or are deploying CBRS and OnGo solutions, and want to share some of the kind of the next level of detail behind that. And then set it up to talk about where in the gas, oil, energy field, where this is applicable. So the biggest thing that we've learned, I think, is that OnGo and CBRS are not necessarily a replacement for other connectivity technologies, but complementary to. And because it has unique characteristics, as Alan talked about, in terms of its security, its the high bandwidth. And then when we present this to organizations, what they realize as part of their enterprise connectivity portfolio, that it's unique because, as the picture shows here, it's kind of its own HOV lane for connectivity, because it is licensed based on geography, basically where you are. You get a relative exclusiveness to access to the spectrum, and it's not congested and competing like Wi-Fi, so it's not that open. It does have a couple barriers to entry, but it's not as restrictive as going to a national operator where maybe the business arrangements and so forth aren't maybe as convenient. So we've found with enterprises that having an ownership of spectrum and using technology in which there's components readily available gives them a sense of ownership and independence that they've been striving for. And when they realize this, and it's usually to solve one use case to begin with or a problem, but they get kind of addicted to it. That, okay, now I have this separate way that I can manage connectivity that's very flexible for my organization. And as Alan said, CBRS is the frequency, and OnGo is really the solution part of this, because what the OnGo and CBRS Alliance have pulled together is the full ecosystem to actually be able to use that roadbed, that HOV lane of CBRS, and built the cars and trucks and the gas stations and all the traffic signs that you need to make that roadbed useful. And I break that up, and our membership is certainly along these lines. We have, as Alan talked about, the Spectrum Access System, so which there's 5 companies and even more in the pipeline approved. There's the radio access network, the access points, which could be for indoor, for simple basic use, to fixed wireless systems if you're trying to do point-to-point connectivity, to multi-service radio systems, we'll call it, that handle multiple connections, scale, indoor and outdoor, and can be an enterprise industrial type solution. So already within the CBRS Alliance, there's certified products and infrastructure on the market deployed today, meeting any mix of these use cases in the radio area network. And the 4G and 5G services are provided by a variety of different vendors and options, whether it's the mobile network operators, or you can do a private network, or there's cloud service providers, and bringing that 3GPP technology that's ubiquitous to create the solution to connect, as Alan said, all these different types of devices. The CBRS Alliance also has vendors and companies that are bringing system integration and service providers and all the applications and use cases together. So that's what makes OnGo different, in that it is not just the frequency, it really is the solution. OnGo also kind of transcends the traditional other wireless connectivity from Wi-Fi to cellular. This picture kind of shows that within the systems, as this is new, a lot of the products and solutions around OnGo are really modern. They're not encumbered by past technologies. They often either run in the cloud or in your data center. As Alan said, they kind of deploy more like Wi-Fi than they do like traditional mobile cell tower technology. And they span the whole geographic area from in-building all the way out to remote distributed sites, where Wi-Fi is very good indoors, or where your known locations, it diminishes as you move out. Likewise, cellular is very powerful for the macro network, but it can have difficulty moving indoors. CBRS, because it is 3GPP, interoperates certainly with the cellular. There's things like carrier aggregation and ways to hand off, and devices will often support multiple bands. So you can get that kind of seamless connectivity, and likewise with Wi-Fi, many of the devices will work. So OnGo can also provide that redundant overlay of connectivity. And then on the cloud services, to do all the authentication and management of the system, as stated before, that's available in a lot of different deployment models and business models for enterprises. And just to go even a little bit deeper, as Alan talked about, there's 150 megahertz that's rough and tough broken up in the 10 megahertz channels, controlled by the Spectrum Access System, as shown here is by the rainbow chart, which you can use GAA or PAL. And what we're trying to show here in colors is that spectrum can be allocated for multiple services. It can use a mix of public and private networks, and generally bring that into a system that could be on-premise or in the cloud that is operating as your baseband. You then deploy radios and antennas or access points across the organization or location. And what you can do is you can actually segment and slice your network for different uses at the same time. And that's a unique aspect of the OnGo solutions. And a lot of the work in the organization is working through these use cases and deployment models to be able to service multiple functions, both private and public. And as shown here for just as example on the Ed devices and solutions, you can then break this up and share it and control it. So that provides a lot of flexibility. And as I mentioned before, there's also interoperability to other networks through dual connectivity or having failover or redundancy. That is a real benefit to the system. So moving into the energy industry, it's often driven by what are the use cases and the edge solutions that the industry is trying to solve. And it often starts with one that they're trying to fix. And the advantage is that once you have the infrastructure in place, because of the scalability, the wireline speeds, the security, you can start deploying all kinds of different things that connect together. This is showing some examples. Some of this content was provided by member company Multitech, which provides a lot of edge solutions and devices. But we can do everything from high bandwidth video surveillance, allow for the connecting of gateways that might connect to a different technology that might be LoRa or RFID. We can support some of the low latency, high capacity things like augmented reality, virtual reality, which basically you have to get less than 20 milliseconds, otherwise you're going to get seasick using it. So a lot of these new technologies and things in operational technologies that you want to bring to your industry can now be enabled through this dedicated infrastructure. And you can use it for communications. Internal Motorola makes CBRS OnGo capable handsets for push to talk. And at the same time, you could support your cellular networks and carriers over the same spectrum and system. So I often, working through many use cases with customers, if you were to just kind of back up to what the 4 fundamental use case reasons or drivers are that we've seen in really the last 6 months that it's been commercially released. Surprisingly, from my perspective, the most common use, particularly with the COVID-19, where there's been a new rethinking of how we spatially orient things and have to moving some things around, is actually OnGo provides an ability to replace a wire. Because often the wiring, the power, the network connectivity, the switching, even for Wi-Fi access points, because the Wi-Fi access points, the coverage footprint isn't as big as what you can get with CBRS, which is incredibly large due to the power ratings. You can pay for itself, the system if you're having to move things around. So as we often say, this is kind of fiber without the trench, and it's the wires without the switching infrastructure that you need to have. We're also seeing it in just places where Wi-Fi and cellular just haven't worked out, and they're looking for something higher power, better coverage and capacity. That's often in places like industrial environments, warehouse environments, where there's a lot of interference from just metal and things and stacked high shelves. this provides a much more cost-effective means of connectivity. We've also seen with customers where once they realize that they can have the ownership and control, that they kind of look back and say, hey, we tried this project in the past, really good idea, had a good business case and operational technology behind it, but we didn't do it because we couldn't get the connectivity results. So we're seeing enterprises, industrial customers kind of revisit, dust off their best laid plans of the past, and looking at them under a new light of CBRS and OnGo. And last but not least is 5G. Because of the 10 times order of magnitude improvements in latency and bandwidth and reliability that 5G brings, and the fact that these solutions can often upgrade just with software towards 5G, really kind of makes this a smart choice as we're moving forward. And in the energy industry, and thank my friends over at Multitech for providing some of these, in the energy industry, some simple things like increasing worker productivity by putting in Wi-Fi hot points around a vehicle, have a vehicle area network, a van, and using CBRS backhaul. So you're able to leverage existing Wi-Fi components and devices and so forth, but having that mobile connectivity, because CBRS often, particularly when we're cutting the wires, is we're now providing connectivity over an area and not to a specific location. We also see it as companies want to do a digital transformation, have more things connected, and integrate different operational technologies and IT technologies together. So the advantage of OnGo is we can support high bandwidth devices, IoT devices, for data, we can do voice, we can mix all these different communication functions into a common infrastructure. In the industrial area, also improving safety and security, everything from doing video monitoring to providing better means to meet OSHA compliance or improve training or operational efficiencies, less individuals to be able to augment them virtually from centralized locations is a driver. And then of course, the traditional industrial IoT type use cases of connecting lots of things together. Certainly the power and area coverage requirements of CBRS, or capabilities I should say, are very conducive to the industrial, and the fact that the spectrum is dedicated, in some ways clear and unencumbered, provides a real good use, or it's a backup failover to maybe a wired or other wireless connectivities to provide a level of redundancy that's mission critical. So with that, I will turn it over to IM Services.
Okay, great. And this is Jonathan Shawhart with Cambium Networks. What I'd like to do is talk about some of the different use cases that we've seen in the oil and gas community, and talk about some of the deployments that we've seen with CBRS in different areas within the oil and gas fields. So before I introduce our end user here, what I'd like to do is just kind of give a brief overview of Cambium's unique approach to CBRS. We have a software-defined, purpose-built approach for our outdoor fixed wireless broadband solutions. And one of the reasons we've joined the CBRS Alliance and maintained that initiative as we've gone through the history that Alan provided earlier is because Cambium was one of the largest manufacturers of the 3 gigahertz broadband solutions in various markets. So it was a natural fit for us to transition to CBRS, and we've seen four major oil and gas companies and several independent operators deploying our outdoor fixed wireless solutions since they've been given the green light earlier this year. We meet these needs for CBRS users for fixed wireless broadband with an end-to-end infrastructure approach with multiple SaaS options for the customer. It's completely integrated into our back office management system. So far, we have over 20,000 subscribers, and that's growing. So we see a tremendous adoption of CBRS with our existing users and customers that are moving towards that CBRS spectrum. So to talk a little bit more about that user experience, I asked Ron Ivey to join us. Ron is with IMG Services. He's managing director there, and I'd like to have him join us. Ron, are you there?
Yeah, I'm here. Thanks for the introduction.
Yeah, absolutely. So Ron, tell our audience a little bit more about IM Services and your unique approach to providing connectivity to oil and gas clients across the regions.
Well, IM Services Group is predominantly more of a technology deployment. We do a lot of fiber wireless combination to the end user, to our customers. The primary focus of wireless has probably been to create mobility, the use of reliability when it comes to backup or redundancy. And it's had its issues over the years with shared spectrum, with latency. So essentially, getting into the CBRS, it was an opportunity for us to see some sort of licensed capability where we could create a consistent, constant state of connection to the end user, to the devices. There's been a lot of concern in the industry over the years about whether this wireless technology would be available to maintain those characteristics. So a couple of our first deployments, we saw great success with the product, the deployment, with the ease of use, on the size, and the quickness of being able to deploy the product in the field. So it cut down on our tech time or installation time, typical to more of a cellular or microwave type solution. The problems that we've been solving were more related to how we deploy in the field, how do we interconnect to edge devices, how do we get access to clean power so that we can keep constant state of connectivity. So the oil and gas industry is difficult because there's a lot of dirty power, a lot of harsh environments. But the primary focus for the customers was to get access to remote monitoring, stability, and get access to the data controls, telemetry, and SCADA that they needed for their operations center to maintain a solid and steady state of communication. So,
great. So it sounds like there's not just one or two challenges that you're solving for the industry, but several, and it's not always just related to spectrum, but a variety of different challenges based on the environment and typical deployments for oil and gas.
Yeah.
Ron, what led you? Oh, I'm sorry. Go ahead.
Yeah, oil and gas is a tough environment. It's not traditional to, say, a city or a metro build or a stadium, as we've all probably done over the years. It can be long distances. It can be very remote, unmanned for long periods of time. So it has to be reliable, and it has to show a constant state to get the customers and the clients to see this as a viable solution.
Sure. And Ron, what led you towards using CBRS spectrum for your deployments? And I guess tell us a little bit more about the performance that you're seeing today as you continue to deploy more radios in the oil fields.
Well, we chose CBRS because we saw the opportunity to leverage, the license aspect of the frequency. It's not often that you have access to stay in a band that you feel is protected, and you're going to get that reliability. Open frequency lends to a lot of inconsistency, a lot of changes in the environment, loss of production, outages. And so trying to cooperate in, say a Wi-Fi environment is not exactly a reliable, and it has had its issues over the years of being plagued with a lot of complexities that turn out to be not a solution in the more critical infrastructure type projects. So CBRS, as we followed the rollout of the system, we were prepared. We had the ability to roll out some frequencies for testing as CBRS became available. It was an opportunity for us to get licensed band to our customers to show the reliability and the throughput. If you want to move to the next slide, it might help walk through some of the characteristics of the throughput, the band. So
Is that, go ahead.
CBRS actually provides, because it's a more secure, dedicated frequency band, we can now start looking at it from a reliable network. We can actually attach VLANs, AWS, dedicated DI circuits. We can do tunneling and VPN controls back to operation centers for SCADA telemetry management. So it creates a lot of tools in the oil and gas industry that have been difficult before, where a simulsat connection and a remote pump site doesn't have a lot of throughput, but it's consistent. Here we can offer that consistency and create those dedicated tunnels to their operations center in order for them to monitor and manage those assets without having to do truck rolls or having personnel on site. The big buzzword in today's industry is we're starting a new project last week, and the client is asking for over 45 cameras scattered throughout the project, which is high bandwidth. And their focus is eyes on assets, being able to zoom and monitor activity in the field and minimize their OpEx by not having to do truck rolls on a consistent basis. So the throughput, as you can see here, this is just one example out of many projects. We're seeing an average of about 125 down and 100 up. And some of the projects require that we have redundancy. We have multiple radio links in case we have a hardware failure. We have backup, and that would be a blended, service to where it's redundant at the edge with a switch, with power and backup services. So this is kind of the overview of some of the projects. I think some of the hurdles we had at the beginning, and Jonathan, I appreciate all the many calls we had as we launched our second project, is getting the subscriber modules to register properly on the SAS so that it would recognize the configuration of the edge device. And I think we figured it out through some tests and some different strategies where we had to set the subscriber while it was registering before it could actually take effect and give us our highest throughput. Things that we learned was we assumed that 30 was our bandwidth capabilities and found out 40 was available, and we requested and were granted 40, which helped the throughput calculations on most of our deployments.
Okay. So Ron, your approach to the oil and gas market with CBRS is somewhat unique because not only are you the end user, but you're also providing the service to oil and gas end users. So have you seen any customers that have some hesitancy with deploying in CBRS, or is it maybe a safer bet for them where they've experienced interference in the past, having protected spectrum? Is that really a big selling point for you and when you talk to customers about having protected spectrum?
Yeah, so the client that we just launched a big project with last week was hesitant. It took us probably a month through their IT and operations department to discuss and explain the differences between what they know from the past versus what CBRS offers. Obviously, everybody has kind of a tainted and has experience on some of the failures when it comes to an unlicensed frequency. So yeah, I would say explaining how it registers, how you gain access to the frequency, what it gives them from a reliability, low latency, and a throughput standpoint, essentially landed us a contract to deploy a pretty extensive project. And I think their excitement is the fact that we've found ways to also create redundancy in a low-cost solution. We're using cradle points at the edge for just telemetry and using the CBRS for primary communications with cameras and backup services. So
I see.
definitely think the overview of CBRS helped the client understand the capabilities of using that band.
Sure. And so you touched on it a little bit about network redundancy and your approach to that and how you're solving that challenge for this one particular client. So are you seeing that more customers are asking for network redundancy as part of the deployment strategy, just based on fixed wireless infrastructure, architecture, and whether it be, you mentioned cell modems in the previous discussion, but obviously you also provide fiber redundancy for your backhaul. Tell us a little more about network redundancy and how that seems to be a critical piece in your approach to providing field communications.
Yeah, so I think one particular client asked for fiber as his primary communication, and we put in wireless as a redundant or backup solution. And the purpose for that was they wanted to interconnect an AWS physical link to help operations manage the assets and the telemetry and the SCADA controls coming from the field. So from their standpoint, redundancy and reliability was very important to maintain that connectivity. And another project that we're just starting, it is actually going to be a multi-tower wireless connectivity to the edge to support a redundant fashion, which what we'll do is we'll set up a couple of towers in opposite ends of the project, pretty extensive project. And we'll use both of those towers to create a redundant link using CBRS. One is a primary and one is more of a hot standby or backup. On another project, we're deploying a CBRS out to the field and using Cradlepoint as a low bandwidth SCADA solution, just in case there's failures or a hardware issue on a subscriber module or whatever that issue might be. We still have telemetry, which make them feel comfortable that the controls and the SCADA is still, transmitting and getting back to operations.
Sure. So I know that you did a lot of research, not only in determining the best frequencies to operate in, and we talked about why you chose CBRS, but you also looked at different technologies from a technology vendor perspective. Why did you choose Cambium for your network deployments?
Well, I have a couple different networks that operate throughout the country, and one that's in Southern California. We tested out some technology, and we found that it's mean time failure, hardware, other issues were starting to emerge. I've been using Cambium and pre-Cambium for many years. So the reason why we stuck with Cambium is we felt that one, the ability to manage our assets from subscriber modules to the arrays. Now we're looking at the micro pops. All of those sit in a suite that we can see, manage, get SNMP, and monitor the entire network from one interface. That was one large benefit. The other benefit is it's solid solid product. I've been using it for a long time, and I've not had a lot of meantime failures or issues with the product. As you know, Jonathan, the support's been great. I've been able to reach out and get some technical questions addressed. Being able to RMA product if we've had a couple of failures here and there before we launch the product has been excellent for us. So I think over the years we've learned that it's a solid company, solid product, and we decided to deploy it in the last 3 projects and been very happy with it. Great,
good to hear. Ron, you mentioned some challenges with CBRS and kind of, you know, the early days of the adoption and moving towards deploying radios in GAA. What other, you know, lessons learned, and I see that you have that on a couple of bullets here. Maybe tell us a little bit more about, you know, noise floor mitigation and what you're seeing in the oil field as far as maybe other users that are in this frequency band, or has that been an issue at all as far as you know, neighbors causing interference with your deployments?
Well, I think the biggest issue we've seen so far is just it's new in the industry. It's not like we've got 15 years of education and documentation about how to roll it out, what the software and the SaaS is going to give us. And so obviously in the many calls we had, it was kind of a test and examine and prepare ourselves to distribute that to the techs and the team to move into the CBRS and get our product up and running. You know, some of the things we learned is related to how to register, how we get that license. We did roll out several arrays and determined that perhaps we should have determined the noise floor a little bit better before we registered a specific frequency group. So we had to make some adjustments and actually, you know, change several times. So I think first thing is getting up your assets and determining what that noise floor is looking like, how we should register and where we should register. And then tips would be is to set your SUs during the registration process to maximize your throughput. I think those are the primary things that we learned. Everything else is standard process. Would it be setting up the timing modules or the arrays or interconnecting the power? It's all pretty typical.
Sure. Well, I mean, you guys certainly are one of the pioneers of deploying CBRS in the oil and gas fields, and I think your unique approach is that you have multiple customers in different regions where you've done this, so you have a good sample size and have that experience to lean on when customers have questions about how they can deploy as well. So that's good information to share. Last question, I guess tell us about, you know, long-term plans and your network expansions. You mentioned a new customer that you're starting to do a deployment with. Are you seeing your existing customer base and other customers start to say, hey, we're planning for, you know, the second half of this year and into next year, we'd like to, you know, start this process of expanding the network, and you know, tell us a little more about, you know, the future for IM Services Group.
Well, you know, just to be frank, I think obviously everybody's seen the oil and gas industry take a hit, and there's been a little bit of spook in industry layoffs. So it hasn't really been a big push lately. We've had a couple of clients express interest in perhaps maybe slowing down a potential project and maybe removing some fiber and looking at wireless. So there's some OpEx, CapEx changes going on in the industry now. And so wireless is now being looked at as a potential lower cost solution on 2 projects that we're looking at now. And so it would be, how do we provide a solid solution? We use the CBRS. How do we mitigate some of the capital expenditures? We use wireless instead of maybe more fiber. So those are the strategies that we're discussing with a lot of clients right now, is how do we work with them on a troubled time and a little bit of difficulty in maintaining capital or budget that they've kind of carved out for a project. So.
Okay. Yeah, that makes sense. So you're really it's shifting the business model internally with these oil and gas users, and looking at it as more of a OpEx savings versus a CapEx expenditure for the foreseeable future.
Yeah, and we are seeing some of that. Also, there's some Canadian interest in a couple of our clients about leveraging wireless now as a potential solution. So I think in general, the industry is starting to look at is that readily available, and does this provide the reliability? And it's new, so it doesn't have a lot of press actually to communicate to the executives or the design team or IT management what is it that this is going to offer. And so it's really word of mouth right now, and some of the projects to educate them, provide them the information to show them how this is rolled out and what it could do for their communications network.
Excellent. Well, Ron, thank you for joining us today. We really appreciate your insight and really boots on the ground view of what's going on out there and your experience with these multiple deployments. So very, very helpful in that ongoing discussion about how CBRS can be leveraged for oil and gas and industrial customers. So we really appreciate your time today.
Yeah, I appreciate the opportunity, and I have to thank my team too, not just myself, but a lot of team members putting together the entire network and deployment. So I appreciate the opportunity to speak.
Excellent. Okay, well, I'll hand it back over to the other panelists, and I think we're going to have a open Q&A session with the attendees.
Yeah. Thanks, Jonathan. This is Greg. A great discussion, guys. We've had a couple questions come in, and we've got a few minutes to go through them. First, I wanted to ask a question, and I get this question probably more than any other question about CBRS, and I figured the experts here would have some good insight on it, and that's the SAS connection and the concept of the heartbeat and how that works and why that's important, how long you can go without a connection to the SAS, and what the what the requirements are. Do you have to discontinue service if you lose that connection? And are there best practices in terms of redundant connections to the SAS, particularly in more rural and remote areas, to make sure that connection is maintained? But if just someone could generally talk about that, that's probably the biggest source of confusion I get about CBRS.
Yeah, this is Kurt. I can take that. You're right. You have to, the frequency is granted, and the SAS, when you initially register your radios and you do it by location, there's a step of registering, but then once you're registered, there's a heartbeat to let the SAS know it's alive, and you know the SAS is alive. If you lose that connection, there's a couple minutes until you're going to have to either cease operation, or if the SAS tells you got to change channels because there's an incumbent. And this is primarily only going to happen near the coast, where there's which is the only dynamic part, which the Navy radars, the fixed satellite sites don't change really. So you will have to turn off operation. In terms of best practices, having a secondary route that can connect will help. And then the other big thing is make sure that when you work with a vendor, and this is certainly something that we've implemented in our RAN solutions, is that you don't re-register your devices, because then the SAS has to go through a recalculation. You just resume your heartbeat, and then it'll come right back up. Because the grant that you're given is good for up to 7 days after you lose a heartbeat. So if you're granted access to a frequency spectrum and you have an interruption of your heartbeat, a couple minutes later, you'll have to stop, come back up, reconnect. You'll get that exact same grant. So nobody else is going to come steal your frequency. But if you re-register, then the whole process starts over again. And then that's what you want to avoid. But the vendors will walk you through that, and there's definitely techniques and best practices out there already to make sure you've got the most reliable system possible.
Oh, great, Kurt. That's helpful. I appreciate that. Question from one of the listeners about voice over CBRS. There's obviously voice over LTE. Is that type of technology appropriate for CBRS use, or how is that handled over CBRS without a carrier? You see a lot of voice on CBRS. I guess that's the initial part of this.
Yeah, there's people that start from different starting points. A lot of it is data, and others, as I said, these initial use cases has been more of our competition hasn't been Wi-Fi or cellular, but wires, which we're replacing wires. But the technologies exist already for multiple ways that you can do voice. You could do over the top voice and solutions, and there's folks that have that. That don't require you to have that connection to an EPC or a core connection with an IMS for voice. There is work under what the technology exists, and I would say it's more of the business models that are still being worked out to allow roaming and interconnection to so you can roam in and roam out. Already, and there's already solutions from some providers already for that. And then last but not least is connecting to the MNOs and the MSOs, or the virtual network operators that have core systems. The nice part about CBRS and OnGo is the solutions, the standards and the specifications are all there. And it's really just kind of the business models that have to be sorted out as it grows. But you can get with your system integrators and start having those discussions. We have people that have implemented voice in those various forms today. And my personal opinion, not a company position, is that once the PALs have been resolved and that auction is complete, that there'll probably be an acceleration of multiple types of voice services and other services than what you see today.
And to build on what Kurt's saying there is, keep in mind, this is in many respects stock standard LTE just in the CBRS band. So everything that we enjoy, and phones that are enabled in band 48, they can do the same job in band 48 they can do anywhere else. It's just a matter, as Kurt was saying about the infrastructure, how is that voice carried? And there's multiple ways that voice can be carried. But all of those are supported. It's only limited by, imagination almost. So.
Okay, great, thanks. That's helpful. One other point somebody raised, I think this is as much as a question, is just a reminder, and Alan covered it in his presentation. There's many vendors that are affiliated with the Wi-Fi Alliance and OnGo. So we're giving one use case.
CBRS Alliance.
CBRS Alliance, I'm sorry, CBRS Alliance and OnGo. We're giving one use case here, not an endorsement, but just Alan had a slide with a lot of vendors and other parties that are associated with this. So we should look into it. But I think this was a great discussion. Thanks everybody for joining. Feel free, the people on this call, reach out, contact the participants on this webinar if you have additional questions, and stay tuned for more information from NLEC on this and other issues over the rest of the summer. So thanks for joining.